This is Project Synapse. If you know what it is, then this explanation is boring, but it's three people, Marcel Gagné, Jean Pinard, and me, that get together every Friday morning to talk about AI. We started it out as a self-help group talking about things and sharing knowledge, and it's become a bit of a popular show, actually, with the podcast. Welcome, Marcel. Welcome, John.
Thank you. Thank you. Hey, before we continue, I have to ask, I'm in this room upstairs. As people can tell, if they're watching us on YouTube, they can see that I'm in a room surrounded by windows, which means I have cardboard cutouts blocking out the windows on the other side so that I'm not bathed.
Good
in
for
sunlight,
you.
And I don't. Thank you. I actually
$50,000 worth of windows, and you've got cardboard on them, so you look like a boarded up shack. Way to go. You know.
I only do it for the podcast. I also have a little tiny room air conditioner behind me, and I must ask immediately, is it making too much noise before we continue?
No, it's fine. Yeah,
Thanks
but I got a lot of people walking down the street going, I thought that Gagné guy was doing okay. Now his windows are boarded up, and even with cardboard.
Can't even afford curtains.
Like to get custom triangular, like there are triangular windows, basically a big triangle up at the top. Try to find blinds that fit those things.
Cardboard. Put it on your windows. Jeez. The neighbors are saying...
Make me sound like a terrible person.
The neighbors are saying he was fine. I invited him over for this barbecue, though, and he started just talking about AI all the time. He was fine before that. He used to come over, do a couple hamburgers, maybe a beer, which is, by the way, the subject of the show. And I wanted to do that for the May 2-4 weekend. If you're listening in the U.S., I don't actually know what the holidays are in the U.S. I try to find them out because we take them on the podcast. I always take all the holidays. I figure it's the thing I can do for U.S.-Canada relationship is to celebrate the holidays from both countries. What a guy, eh? But this is the May 2-4 weekend. We call it the 2-4, named after the Canadian case of beer, or the 24th, which was supposed to be the Queen's birthday. This is the time everybody gets out to their cottage, cabin, whatever. It's the first start of summer. So whether you're out at your cottage, or whether you're out at your cabin or your trailer, you're on a lake, or you're just in somebody's backyard going, hey, that barbecue looks good. How do I sleaze an invitation? There's always that point when dinner's done, you're sitting back, you're relaxed, maybe you crack a beer, and somebody turns to you and says, what's this thing AI all about?
Oh, I really thought seriously, we're recording, for the people who don't know this, we're recording this on a Friday morning. And I really thought seriously, should I actually crack open a beer for this? Because somebody said, this should be like hanging around a barbecue talking about AI. And instead, I'm cracking open cold Blue Menu sparkling water from President's Choice.
I've got my usual coffee.
Oh, God.
But we're going to pretend. So, okay, here's a question, and a legitimate question when that person turns to you and this is a person who knows nothing about AI, whatever, never seemed interested. All of a sudden, they turn to you and say, what is AI? How would you answer that?
I would start with a song like, what is love? Anyway, no, actually, the very first thing I would point out is the idea. Sorry.
Okay. I have to tell you, I think there's probably vodka or something in that sparkling water that Marcel's got.
There may not be beer in there, or
it's hot in here.
Or he's cover the windows up.
Let's go back in time, okay? Let's go back a little ways. And I know you're going to think that I'm going to go back to the 1950s, but I'm going to go back to ancient Greece. And in the ancient Greek myths, it was said that at Mount Olympus, Hephaestus had created what we would think of today as androids. He had created these mechanical servants, essentially artificially intelligent robots. Now, there was one big one, but there were also a whole bunch of tripods that also had wheels that would basically just scoot around silently in the halls of Mount Olympus, or use the tripod arms to manipulate things and move around and stuff like that. Those things were in the Iliad, the most ancient Greek myths that we've got. A description of basically artificially intelligent robots was already in vogue back then. So you have to go back a long ways to start thinking about this idea of humanity wanting to create effectively intelligent servants. Did you know that?
I knew that, but then
Oh, you knew
I'm
that?
on the program. I'm on the program with you. I'm not sitting
I
in your
know everything.
backyard.
Yeah.
I'm going to start closer to this century because I thought about this. When you say, what is it? I say we're actually witnessing today the early development of a new form of intelligence. We could say it fulfills the promise that we could put this together and fulfills the promises that we've put into fiction. So a lot of those things that you've been reading in science fiction are coming true. Now, it looks from the outside a lot like we do. It's still very primitive. And what you're seeing today is very primitive, but it's moving at an incredible rate. And in a year, 2 years, 3 years, it doesn't matter, but a very short time, what today you're going to think of as the most primitive form of it that you ever saw. And that I think that's my explanation. John, what's yours?
I've talked about this before on the show about a 2-year-old PhD. And I guess when I was thinking about it in preparation for the show, everybody's always known somebody that knows everything about everything. And to me, this, I'm thinking of ourselves.
I'm not thinking about anybody in particular.
So to me, artificial intelligence, not Gen AI, but artificial intelligence to me is the computer version of that person that knows everything about everything. And you can ask it anything and it will give you an answer.
Okay. So
I'm gonna try to balance those 2 points of view, okay, Jim? You talked about the idea of a new form of intelligence. And I think that it has taken us as human beings a long time to get used to the idea that we're not the only thing that can think on this planet. At one time, we had this weird idea that basically animals just reacted simply to stimulus, whether it was hot or cold or hunger or something like that. And there wasn't actually anything happening in those brains. And I think for most people, most intelligent people on this planet, we've come to the conclusion that not only are animals intelligent, they are also a different type of intelligence. When we talk about artificially intelligent, I have struggled with that term personally. And when I think of it myself, I tend to like to use the term synthetic intelligence. Because yes, we are creating something that's different, but that something is not necessarily artificial. It's just different. And I think synthetic for me works better in that respect for precisely that reason. It's just different. And we have to contend with the idea when we start talking about artificial intelligence that there are different forms of intelligence. Now, what we're trying to create is human-like intelligence, something that can converse with us as we would, well, to use John's expression, the PhD, or one that is growing up very quickly.
Yeah. So here's the next question. Now you're sitting, you're relaxed, and you think you've aced that question. You got A+ with this one. And then they turn and say, so how's it work?
To go with how it works, I would actually like to go back to the 1950s. I'm not going to go back to ancient Greece here, but I'm going to go back to the 1950s. And in the 1950s, that was kind of like the first golden age, so to speak, of artificial intelligence. And they had this idea that if you gathered all of the top minds in IT at the time, which were like a dozen people or something, into a room over a weekend, they could create effectively an artificially intelligent system. I'm oversimplifying here, obviously. But the idea was that we could just feed it a whole bunch of, what's a dog? A dog is this and it does that. What's a cat? A cat is this and it does that. Effectively, create a laundry list of the things that humans know about and interact with. And if we put enough of these things into a computer using a question and answer thing, we could basically solve any riddle and answer any question. That was like way beyond what was possible at the time. There were something like that could conceivably in some universe work, but those were what we'd call good old-fashioned AI. It's actually shortened as an acronym GOFAI, GOFAI. So if you ever see that, that's what it's talking about. It's a system where basically you just... It's basically a system where you have a whole bunch of facts that have a tree, a decision tree that you go through. Is it this? No. Is it this? No. Is it this? And so on, all the way down. So that would have been the first attempt at artificially intelligent systems. And of course, it didn't work. And we went into what's called the first AI
It's a good idea,
winter.
though. And I like your description, a decision tree. And that's, we thought we could automate that decision tree. If our neighbor just doesn't know anything about IT, might have to explain a little more about this, but that's really just like a program.
Yeah.
If then
absolutely.
You follow through this and you can eventually get your way. You can write a program big enough to understand the world.
But those systems were, if I can use this term, brittle, as in they broke easy in the sense that they couldn't deal with fuzziness. Because if you were talking about the idea, it's a four-legged animal, there are a whole hell of a lot of four-legged animals. And there are a whole bunch of four-legged animals that have hair on them as well, for instance. And eventually that system would break down because in reality, there wasn't any of that fuzziness. That decision tree would fall apart fairly quickly if you had the computing resources that we have today.
Yeah, I think from my standpoint, I would maybe to oversimplify it as far as explaining how it works is that people fed the creators of artificial intelligence fed it with a whole bunch of information that they initially got off the internet or other places to help.
There was no internet at the time.
I guess I'm thinking ChatGPT times, right? So the creation of ChatGPT and those that feeding it from things like Wikipedia and so on. But yeah, it doesn't really matter where the information comes from, but it was feeding the system with a whole bunch of information. And then you could just ask it questions and it could go back like a brain. It could go back into its brain and get that information and feed it back to you.
That's true. But those old systems, they didn't learn. They had locked in information and they had no ability to learn or acquire new information. So we get into the 2010s at this point now. So we jump forward several years. We've gone through a couple of AI winters. There was an AI winter shortly after that first attempt. And then there was an AI winter back in the 80s and so forth. AI winter just means we got all excited about the idea that we had all these new things that we could bring to bear to create these intelligent systems. And then everything just fell apart because honestly, we just did not have the technology. We didn't have systems that were powerful enough. We didn't have the storage that we've got today. We didn't have the speed that we've got today and so forth. And what happened in the 2010s is we got into this thing called machine learning, where we basically fed the system data. Lots of data, symbols, probabilities, like in the sense of sometimes it's this, sometimes it's that, and you have to decide whether something is more likely this than that. And things started to accelerate at that point because now instead of trying to feed a whole bunch of information into a system, which is what we did with things like Deep Blue, who beat Kasparov or in chess. We had a system where we basically fed it every single game of chess that was ever played by a human being, right? And it was able to access that with incredible speed, but that wasn't the kind of machine learning that we've got today, where the systems actually learn information. And Jim, you're a musician. John, you're a musician as well. So you know that just the fact that you know where the fingers go and you know where to touch the keys on a piano or something like that isn't enough. You have to practice, right? You keep practicing. And when you practice, the more you practice, you develop both muscle memory and a kind of internal memory as well. Because as they say, practice makes perfect. What's happening in your brain is there are parts of your brain that are reinforced. We'll use that term with AI as well, reinforcement learning. But there are parts of your brain that see this information over and over again. And that reinforcement makes it so that those particular memories, those muscle memories, those musical memories and so forth, never leave you because you have reinforced them to the degree that if you're going to sit down and start to do something, you'll be able to call it all up instantly. In terms of computers, we call those things neural networks. Effectively, mimic or mirror what it is we do with our own brains. You look at certain bits of information, that information, whether it's music or whether it's painting or whether it's your math homework that you need to study for a test, that information, you go over it and it gets reinforced and that becomes the type of information that the system can access quickly and easily.
Yeah. And those neural pathways, they become weighted, I think is a really good expression of it. It's been used a number of times. Therefore, when this happens, this pathway gets precedence and it follows that and it more or less executes automatically. Now, that's just oversimplification, but we did create these neural networks, a version of that. And that's what happened here in Canada, I think, with Geoffrey Hinton and others. He really led that pack of developing that. We now had the hardware to do this and a method of doing it. Did you want to go further with, you want to take us into the future any further, Marcel?
I guess what I wanted to take it from there is So we get into, so now we've got machine learning, and then eventually we develop into what is referred to today. And I'm trying desperately to avoid all the acronyms here. We get into what's called deep learning. And with deep learning, we've got neural networks that basically build on top of neural networks. You can start to recognize all, not just words and connections between words, but you start getting all sorts of things. You can recognize images, you can recognize sounds, you can recognize all sorts. And we call this like multimodal at that point. Multimodal means that there are different ways of looking at information, but you start being able to not just know that the is a word which comes up, which is why when people talk about the idea that it's basically autocorrect on steroids, is a gross misrepresentation of what large language models and neural networks actually do. These weights, this ability to understand that certain things come up more often is actually what's really important in something like that. And if I were to say from here to, and you might try to struggle for what the next word is, and an AI might, but there are things that you can learn in context. If I'm talking about old movies or books or something like that, you wouldn't think from here to there. You would think from here to eternity or something like this, or to eternity and, of course, beyond.
I thought that was infinity and beyond.
Oh, yeah. Sorry, to infinity and beyond. My apology. My apologies to the fine people over at...
We'll talk about the errors in AI later.
Yes. This is Marcel on hallucinations.
To the errors that we have in the human brain.
I get.
Oh, there you go.
Yes, and then there's.
So my answer to that would be similar to yours, but if I was asked how it worked, I would say it depends, because there's hiding under this. There's a lot of different types of AI, and the machine learning, the first one that came up, was really it just learned a lot of patterns, much the same structures we're talking about. It learns what the patterns are, and it can start to recognize patterns. If it sees a pattern, it says, oh, I saw that pattern, report that. And that was the early machine learning. We then went on to a different type of learning that said, hey, wait a minute, if we can recognize patterns, do you know that languages are essentially patterned? And that when you take a look at it, you actually go through it. Anybody who's done a puzzle knows, for instance, that if you've ever done one of those puzzles where you get nothing and you've got to fill in the letters, everybody knows that E is the most frequently used vowel, and it's going to appear roughly so many times in it. And you start to learn these rules about language. These are really primitive in this point. But when you actually start to weight this, and then you take in and absorb tons and tons and tons and tons and tons and tons of language, and you find a way to remember that in terms of what we talked about, not as words, but as vectors, as mathematical expressions, start to know what is more likely to occur when something else happens. And this is an enormous undertaking. It was fine when they first started this, predicting how a sentence goes. That's autocorrect. The next word you're likely to use, that's autocorrect. That's relatively simple. And you really don't need AI to do that. You can do that with a simple algorithm. It's not that hard. But now try and get the works of Shakespeare. Now we got something going there. But I can predict things more or less. And it's the probability. And this is the difference between artificial intelligence at this level and intelligence is it's going to tell you what the most probable thing is. And that happens. We got that into language. That grew rather in a sophisticated fashion to this thing that could write poems. It could reconstruct novels in the style of an author. And the trick is, and we talked about this earlier, why couldn't we do this earlier? It takes a massive amount of computer power. Nothing that you or I would even think about. We talk about the chips. They discovered that graphical processing units were the ones that make the pictures work on your PC and deliver all of the images, because they've got to do a lot of things in a very short period of time. They discovered this
simultaneously.
And they discovered that they needed these chips. These chips that we're calling weigh 15 kilograms. They're not, or more. They're huge. And the systems that run them are huge.
The chips aren't that big. The cards are big because you need all sorts of fans and things to cool them.
Yeah, absolutely. But what I'm saying is that this is just a massive amount of computer power. So it can predict with probability from all the things that it's seen what the next word is. That's one method. There's another method of AI, and it's called diffusion. And most people have heard of stable diffusion. And it basically says, I'm going to take everything I see pixel by pixel. I'm going to break it down, and I'm going to build up that in probabilities by essentially taking the noise out. I'm going to take out everything that's not the picture. You're the one that's going to predict the probability of the next occurrence of a next token. That's what words are referred to in AI parlance. They're really a word, or a part of a word is a token. And so those two things are fundamentally different, but they are being both used. The one we most know is ChatGPT, and that's mostly the language one. But there's all kinds of things. So the answer is we're using a vast amount of computing power to be able to express our knowledge as a mathematical equation, a vector, and we were able to interpret that. It's taking a massive amount of computer power.
And we, as in the people who use these things, have been teaching these systems for years without actually knowing about it. Those captchas that you have when you visit a website that says, click all the pictures of a traffic light or these sorts of things. You have been training human reinforcement of machine learning. You've been involved in that process for years every time that you clicked one of these images and so forth, by helping the machine to understand where the fences are in a drawing or in a picture or something like that. Because the AI needed to learn by looking at millions of these things. And by the way, you were walking into a landmine there, Jim. I will happily walk into for you if you want, which is the idea of, is the AI just copying and stealing all this? In other words, it's looking at these pictures, and I don't think that I can get past the rest of the show without addressing this in some way. Let's hold that one for a second. We're going to go there because you mentioned diffusion.
One of the questions is going to be, is it ripping off my stuff? Your neighbor might be a songwriter or a novelist. You never know. The novelists drink beer around campfires too. There you go. Yeah, me too. So the next question that comes up then is, so it doesn't think?
I'll go. I'm willing to go there. John, do you want to take a shot at this?
I don't know if I was going to say that it thinks, but it reasons. It can interpret what you're asking. It can interpret the information, and it can spit out information out of its database that relates to the question you're asking. So is that thinking? I don't know.
Just in case, you seem to be waiting there, Marcel. But
Yes,
John
I'm
tends
done.
to be
Sorry.
concise. Yeah.
I'll do this when I'm done.
Or you can say over. Just hold an old CB radio microphone in front of you. Yeah, that's over.
XNY 556, A for Apple. And if anybody gets that, I will send them a free copy of my book. Anybody who understands what I just said, I'll send them a free copy of my book.
Oh, there you go. Anyway, are the systems intelligent? I'm going to say actually yes. I'm going to jump right into that and say yes. And here's the reason. We define, first of all, we're going to run into this because we have to define whether are human beings intelligent, or are we just machines that are pattern matching things in the same way that computers are? But if we assume that we are intelligent because we take in information and we have the ability to massage that information, to associate it with other bits of information and spit something out that's new or different or something like that, then yes, AI systems are in fact intelligent. And if we go back to those old systems, those old GoFi systems and so forth, the reasoning there was just step-by-step reasoning. If this, then that, possibly blah, 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 and we break off. The intelligence at that point wasn't really intelligent because it was engineered. Nowadays, things are different. We have systems that use knowledge as implicit bits of information in these neural networks, these reinforced networks that we're talking about. And the reasoning in these systems, the intelligence is trained on a whole whack of information. And its reasoning and its ability to respond, to give you an answer, is an emergent property. In other words, there isn't a step-by-step. This is why people talk about the black box problem in artificial intelligence. There isn't a step-by-step. You ask me this question, I look this up, and therefore this is the answer. There isn't anything like that. The reasoning and the answers that you get from these systems emerges from all of this information put together and the associations that the model makes in its own brain or its own, whatever you want to call it, as it's trying to answer your question. Does that make sense?
No, it makes sense. My answer to does it think is we don't know. And it's really that simple. And I'll add to that with another question, which is, what do you mean by thinking? And that's why going back to my first definition is it's a new form of intelligence. We don't understand what's happening in those neural networks. But the one thing everybody can tell you is we know theoretically how they work, we know how they should work, but in the same way that we know that neural synapses fire in the brain, but we don't know what thinking is, we know that these vectors and these weightings of these neural cells or network nodes, this artificial intelligence, work to achieve a result. We don't know how. The most we've ever tracked, and right now that people have tracked, is like one simple little firing of synapses, or I don't know what you call them. You
mean like in Project Synapse?
Yeah, that's where we got our name. Jeez.
Just to your comment, Jim, about do they think I don't know? There is no doubt AI is intelligent. It can reason, but both of those do not necessarily mean that it thinks.
I think therefore I am. I think therefore I am. If we define thinking as sifting through information in an intelligent way, then yes, machines think. Whether they are conscious is another matter entirely. But I would argue that they most definitely, without a doubt, think.
If you watch ChatGPT now, it actually comes up and tells you what it's doing. And so my answer is it thinking? I have no idea, but you'll think it does. And like I said, we'll go back to alternate form of intelligence. The question, is it conscious, is another question, and which gets to another thing. But I want to back up on this just a second and say, this idea that you talked about emergent properties in something is not, we toss it off, but it is something that we don't understand. At a certain point, we don't understand why things happen. My big example is geese flying. If you take a look at geese flying, they will look like they have a leader, and they will look like the leader changes and that they're doing all of this. But actually, if you go and simulate that in a program, what they're doing can't happen. They can't see and move fast enough. It's just not possible. So what they've been programmed to do somehow, we don't understand how, is when they fly in formation, they follow various rules. And you can start to extrapolate what those rules are, stay this far close to someone, and relatively simple rules generate these amazing patterns that we think of as leadership. It's not. And like I said, people have done some very clean work on this to prove that physically what you're seeing can't happen if you follow the question of, I'm the leader now, I'll go fly up there, you all follow me. Just doesn't happen. So what we see and what's happening are two different things. And we don't understand. Maybe that's a group form of intelligence, for all I know. So we don't understand what intelligence is, so it's impossible for us to say it's happening or not happening. Now, do these things run an internal monologue like we do? I would answer yes at this point. Now, whether they hear it the same way we do, but ChatGPT right now and other AI are running an internal monologue. They're saying the user wants this, they want to have this, they want to do this, they want to do that. Is that really happening in the same way it happens in our brains? Nobody knows.
The bird thing, though, has been recreated, actually, using computer systems. It's called murmuration for anybody who wants to take a look at it. First of all, there's the flocks, like the geese deciding who the leader is. But there's also this thing where you watch these clouds of birds move together, and they seem to follow patterns. You can almost watch images being drawn in the sky as this stuff happens. Maybe it's like a kind of diffusion. Who knows? Anyway, the idea of emergent properties, though, is that things happen as a result of increasing complexity in a system. I'll give you an idea. You've got like a single bee. A single bee on its own can only do so many things. It has certain memories and programs that allow it to point out to the rest of the group where something is, the little dances that they do and things like that. But you get a bunch of bees together, they start behaving together as a group. A single bee will not create a hive. But a group of bees together somehow has the knowledge and information necessary to put all of this stuff together, to decide which group of bees will do this job, which group of bees will do this job, and so forth. And we either decide that bees have this incredible amount of knowledge, or that somehow when you put a whole bunch of simple systems together in a large system, different properties emerge from that system. And even with human beings, we talk about crowd behavior as opposed to individual behaviors. People in crowds will do things that they would never do as an individual, because a different personality, a different type of consciousness emerges from the fact that you have this one intelligence all of a sudden working as a group with 100,000 other intelligences. There was actually something that was published 2-3 weeks ago or something like that, where one of the big AI systems found that while they couldn't predict the movement of a single individual in a crowd, they could predict the movements over time of large crowds. And they did that by analyzing the data from the running of the bulls for the last several years with cameras from different locations, looking at people. And then the AI would suck up all this information. And from that, it was able to tell you how the crowd would move, where it would move, how much of the crowd would break away from the mass to move to a different area, and so forth. And if we as this emergent group intelligence can be predicted with that kind of finesse, it says something. I'm not entirely sure what the answer is at this moment, but it definitely says something about emergent properties.
Do they think we don't know? To me, and I'm going to take that and put it into a corporate environment for a second, because to me, this is...
I'm absolutely certain in the corporate environment.
Nobody
trust
thinks.
me.
But to me, that's one of the problems that we have with the use of AI, or some corporations have a problem with the use of AI in a corporate space, because go back, we've all been programmers at one point in time or another. And one of the things you always have to do is you have to know exactly what the program is doing and be able to test it, that says, if I put in A, I should get out B. The problem is that in a lot of cases, people can't do that with AI because you can't predict what AI is thinking in the background.
No, not to the specific level, but again, part of it is you get down to what thinking, and I don't want to get down too far into neural psychology, but there's a great book called Thinking Fast and Slow. Daniel Kahneman came up with this idea that says, and he didn't go into the neurology of it. He didn't say this is how we're physically structured. He says there's two brain systems working. He called one System 1 and System 2. And System 1, really a stimulus response system. Get a stimulus, it's going to respond. And we run on that most of the time. It's how we get through the world. We could not get through the world trying to interpret every piece of data that's coming at us. We would just go crazy. There are people who can't filter that, and they struggle. So we have this limbic system, and if you're running in the African savannah, everybody always takes us back to the African savannah, where a lion is going to start running after you. You want to run.
You're driving from one city to the other, and you're not.
This is better because I've never figured out how we outrun the lion, even if we do it automatically. So driving from one city to...
You just have to outrun your friend.
Yeah, that's true. That's good. So when you're driving somewhere, everybody's gotten to somewhere, and you've been driving well, but you don't remember how you got there because you were thinking about something at the same time. This automatic system was running. And that is also... So that system's running, and it has its ups and downs. It has its illusions and things that it does to you. But he says, but there's another system that allows us to put that system into check and to be able to do a set of calculations that are above that. And those could lead from everything to being how we become a better person, philosophical things, mathematical things, all of those things that we can do. And I think to some extent, the idea is that which one of those can AI run? And the answer is definitely the limbic system. Definitely System 1. It's doing that. System 2, that's where we have the questions.
So this is to address John's concern about, if it wasn't for John, you and I would totally forget about the fact that the corporate world had ever existed. But anyway,
that's what I'm here for, Marcel.
Yeah.
And we love you for it, John. We do. You are always there to remind us. Are we going to get in trouble for all these musical interludes?
I don't know, because
only
YouTube
if people
will probably
can
get us when we go
recognize
down.
Only if
Yeah,
people can recognize
thank God
what
we're
the song
lousy
is.
singers. No one will recognize.
That,
You know.
exactly. Okay, so you remember we talked about GoFi, good old-fashioned AI, which had these structured reasoning steps. What you're asking for, John, to get this reproducibility all the time is actually the essence of these good old-fashioned AI systems. There's a definitive answer. We got to this answer by going through all these different steps and so forth. And believe it or not, we are at a time now where there are attempts to remarry good old-fashioned AI, which we can think of as, I don't know, structured reasoning, if you like, with modern AI systems, which are the neural networks, the pattern recognition, all that sort of stuff. And they're calling this neuro-symbolic AI. And it's an attempt to structure systems where certain things are a step-by-step reproducible approach. But at other times, we want to bring in the creative aspects because we talk about wanting to create human-like intelligence. Human-like intelligence or human intelligence is messy. It's fuzzy. It's not reproducible from one moment to the next. If you ask, this is why things like first-person witness reports are so unreliable. You say, I saw this happen, and then you ask the person a week later, and they'll tell you, I saw this happen with slight modifications. And then eventually, there's like a whole different report of what actually happened in a situation. Human beings suck at this, and yet we demand this from our machines. But then we want our machines to be able to go beyond simple question and answer. So at some point, we need this hybrid approach. We need systems that are smart enough to understand that for this question, for this problem that you're dealing with, I need an answer, and I need the same answer each and every time. But from time to time, I also want you to get creative and to try to come up with novel ways of looking.
I think for me, one of the things that when we'll talk ChatGPT specifically, but when they first came out with the reasoning model, that when you go in to use it, it shows you step by step on the screen. To me, that made me more comfortable because you could actually see what it was doing, not just give it an answer and mysteriously something comes out at the end.
You saw part
yes,
of what
you're
it
right.
was doing.
You're right. I saw part of what it was doing. But it was still more comforting than just asking it something and mysteriously having an answer come out at the other end.
Can I suggest that the reason we feel that way is because it's still early days?
Yes.
I have to remind people over and over again. I've been following this stuff for a long time, but ChatGPT, most people think of as artificial intelligence, despite the fact that we've already established that artificial intelligence goes back to the 50s. If you want to go back to the ancient Greeks, we could possibly go there. But technologically speaking, with computers back to the 50s, we have to accept that it's still early. ChatGPT was November 30th, 2022. It wasn't that long ago. So we're just starting to get used to this as human beings, that these things exist and that they can think alongside us. And eventually we will get there. But I guarantee you there was probably a time when calculators first appeared on the scene that people were bothered by the idea that they weren't seeing the steps by which it got to 27 divided by 32, 3% of that.
Yes.
And you had to somehow accept that this was the right answer. People were probably really uncomfortable with that even then.
Yeah. And that's why earlier I talked about a 2-year-old PhD. That's because I'm referring to the age of ChatGPT, right? That it's only been around for 2.5 years, but it does things at a PhD level. And I mean, we have to expect that there is going to be growing beyond 2.5 years. And it gets better every day, mind you. Some of the new models that come out give it a few steps back, but yeah, I think that's what we're going to get used to, is that things will get better as we move forward. As Jim always refers to, humans make mistakes, spreadsheets make mistakes. So why should we expect that something like AI doesn't?
Yeah, which is the other question people ask. I hear it hallucinates. This thing not accurate.
I've heard somebody say that their hallucinations are actually a feature, not a bug.
Who would say something like that?
I'm trying to think. Wow, that's the dumbest idea I've ever heard. No, it's just the.
It is. It's an incredibly dumb idea. Who would say something like that?
Also, unfortunately.
Yes. We used to refer to them as undocumented features, also known as bugs.
No, but I think I think Marcel's close to this, and I'll let him jump in and explain his concept. But this is not. First of all, we use the word hallucination, which is somebody said the price of metaphor is eternal vigilance. In other words, just because you can make a metaphor about something doesn't make it something that explains this. Hallucinations happen in the human mind mostly because of a breakdown in something that happens. Hallucinations happen in AI, and why they're misnamed is they're not hallucinations. This is a probability machine. It predicts the probability of the next thing. We give an example where there were two possible answers you could give.
Yep.
The quick brown fox jumped over the lazy dogs. You could, if I said the quick brown, you're going to say fox, right? Because that's the only answer that really
Antelope.
That
brown cow.
If I said, who's my best friend, right? So Jim and his best friend named. Now I know what you're both thinking. Jim doesn't have any friends, but I have more than two friends, right? So Jim and his friend blank. That could go in, and at least give me this, guys, two possible threads.
I'll include your wife, and I'll say 3.
Okay, 3. It depends on the day, but 3. But so depending on which one it weights the probability to, it follows a different path each time, and that's a possibility.
And that's the thing is, it's not necessarily a hallucination. It's not necessarily an error. Probability means it's not 100% probable. It could be this,
but
or
once it
could
takes
be
that turn, it's going to find the probabilities for that. It's not going to. That's why it can't come back and say, "Oops." At least, can't come back and say, "Oops, I didn't do that. I'm gonna go back." I think we're getting very close to it being able to do that, but that's another story. So Marcel, you're the hallucination guy.
Yeah.
Okay, well,
Marcel
there's this guy
more than we do.
Marcel hallucinates all the time. I have special chemicals that I use for that. No.
They're in the lemonade.
Yes.
Anyway, so there was this guy named Pablo Picasso. You may have heard of him, a famous 20th century artist, who is quoted as saying, "Computers are useless. They can only give you answers." Okay. Pablo, using that reasoning, would be very happy with modern systems that hallucinate because they provide us with different ways of looking at things, with different possibilities and different answers than, oh, it's just this. The fact of the matter is, life and the world we live in is messy. There is rarely just one answer. There are many ways to be wrong and maybe not as many ways to be right, but sometimes there are multiple ways to be right as well. There's just always more ways to be wrong. That's just a fact of life. That feature, those hallucinations, is something that we have to understand in how we build the systems and how we use the systems. We have to be able to understand that sometimes, and this is why the hybrid model is probably what we're going to be seeing more and more of going forward. Sometimes you just want an answer. And now what we want an AI system that is smart enough to say, the guy just wants to know what 24 divided by 3 is. But that's it. That's all he wants to know. And I'm not going to sit there and go through all these reasoning steps to do that. I'm going to hand it off to a very simple little agent whose entire job in life is to do basic math. Okay? Because that's what the guy is asking for, basic math. Here's the answer to that question. And I believe it's 7 or something.
I've been struggling with this to try and remember this guy's name, but in the early days of AI, 100 years ago or 2 years ago.
What's my question?
The idea was that you could exit out. AI didn't do math or engineering very well. So he created a whole system that sat beside an AI system that would reach out and get these engineering principles. He was all over YouTube for ages. Now he's disappeared. The name escapes me too. The fact is the same, that people have been doing this since the early days of ChatGPT, or what we call generative AI now. And that tool set's there. People have been saying, there are some ideas that people have put into it. At the same time, when we see this type of problem, we're going to kick off a Python script and it's going to calculate this. We'll compare it, make sure it's accurate. We will get through this accuracy thing. But again, I remind, and we keep going back to this, we think humans are immune to this. And we went into this, our last episode. You think what you remember is true. And every time you retrieve a memory, you rewrite it. And that's one reason why eyewitness testimony is so unreliable. So the more times you remember something, the less accurately you remember it. the intelligence is going to exist with that flaw or feature. How well we can control it and deal with it, that's another story. If we expect this to be an alternate form of intelligence, we should expect that it's going to have at least some of the alternate forms of weaknesses of intelligence.
And with human beings, we would, if we knew someone or worked with someone who was only ever able to give you the answer to questions that there was a definitive answer to, we would fire that person because they're not particularly useful. We value creativity. We value the idea of, look, we've got a problem. I know we don't have a solution to this today, but what are some things that we can look at? The whole idea of blue skying something, bouncing ideas around, we value that. And we should value it in the systems that we're creating as well.
Yeah, following the same pattern. You blue sky it, come out there, come up with the most ideas you can, go back and say, is this practical? Will this work? Will this work? And essentially, for the most part, AI has got that in it now. We exaggerate the number of errors. There are particular areas where errors happen, or hallucinations, if you want to call them that, more than anything. I use this thing every single day. And I'm going to tell you the number of hallucinations, I hallucinate more than it does. And I can't remember stuff like this guy's name that I'm talking about, this engineer, and I've watched his work for a long time. AI could remember that.
So far, I've come up with Hilbert and I've come up with Gödel, and those are not the people we're thinking about here.
Yeah, no, it's driving me crazy. Yeah.
Wolfram,
thank you. Wolfram.
Yes.
Yeah.
God. Okay.
Okay.
And
sorry.
No, and
Wolfram Alpha was the system that you're thinking of.
Yeah. But, and as I was doing, I've typed into AI, trying all kinds of hints to try and find this, couldn't find it, but I've discovered there are at least 15 more people doing this sort of work that were famous that I'd never heard of. And that's the nature of our intelligence. Sometimes we perform better than an AI. Wow.
That's because I know how many R's are in strawberry.
Oh, we're past that, dude. It's like people who point,
we've done the strawberries. Yeah, if there are any Monty Python fans out there,
how to defend yourself against someone armed with a banana.
If you know what we're talking about, send me a note on this one, and I'll send you a copy of my book, Marcel. The other question our neighbor does is says, I've heard it's dangerous. It's going to kill us all.
It could, possible.
Yeah,
The computer could fall on your head.
No, but I think, is it going to kill us all? And that comes out on a lot of things. Will it kill us all? Possibly, but how? More likely, there's this old saying about you're not going to be replaced by AI. You're going to be replaced by a person who knows how to use AI.
Yeah.
I'm more concerned about the person using AI than I am AI. And I'll tell you why. Because will it kill us all? Yeah. People say, can it make an atom bomb? Yeah, I can tell you how to make an atom bomb. You can put guardrails in there, but and we talk about guardrails, and guardrails for my neighbor who doesn't know much about AI are just, they're rules that we put in to say, you shouldn't go here. Don't do that. And they're pretty easy to get around if you're smart.
Yeah.
They function for the most part with honest people, like locks on our doors. They're good with honest people. When we leave the house, when we're going away for a week, my wife says, did you lock every door? I said, what? Because nobody can pick up a bat and knock a window out up here? There's nobody around. So anyway, so rules keep honest people honest. And that's what they do. But what I would put out to you is to say something right now, at this point, AI hasn't learned enough or hasn't advanced enough to be able to do something that we don't already know how to do. And at least the systems you're going to get access to. So the reason why you can make an atom bomb is because that's on the internet. The reason why you can make a chemical is because it's on the internet. Now, there are people who are smart enough, or there are systems that are smart enough to advance beyond that, to talk about get into genetics and things like that. The average guy who's a crook is not going to get their hands on that. Governments will, and governments I worry about, and the former head of Google, Eric Schmidt, wrote a book with Kissinger, and he actually makes a logical piece that says that the natural way that intelligence would evolve and the competition between us and another country is that one of them would start a war. And that is because you're always going to be afraid that somebody's going to get ahead of you. You're going to have the advantage, all of that sort of stuff. And that competition would start a war. It's not an AI starting a war. That's human greed and ignorance and all of the things that we have. So I don't think, honestly, if we evolve an alternate form of intelligence, I don't think it's going to kill us all. I really don't. I think that a logical evolution of this, if you watch Star Trek, the logical evolution of this is not, I'd worry about James Kirk blowing us up. I wouldn't worry about Spock blowing us up. And Spock is going to understand that the needs of the many outweigh the needs of the few. So I think we have a greater hope for intelligence than we think. That's my feeling.
Yeah, I don't think it's the AI that's going to kill us. It may be the guy using AI that's going to kill us.
Yeah.
But until we, and I don't know, we've talked before about Skynet and so forth. And when we get to that point, yeah, maybe the robots will
be back.
The robots will make themselves create these armies that have decided that humans are the flaw on the planet and that we must be eliminated. Makes a great movie.
Okay, but yeah, it makes a great movie. And to reach that assumption, we have to assume that the systems are far simpler than what they are today. Like the AI systems that we have in place today are far more nuanced than they are able to reason and think. Like the whole idea of the paperclip maximizer thing, no AI today would do this. The paperclip maximizer is you tell a system, your job is to maximize the number of paperclips that you create, and that is your one job. A modern system, like a large modern system, would actually think through a whole bunch of other things and go, there are times when maximizing the number of paperclips is not the smartest thing. You wouldn't actually have to tell it that. It would actually be able to figure that out on its own.
But I also
and that is the development, right? The development is find an outcome and plot your way there. And the outcome that you ask it to achieve, it will plot. And obviously, the better you define that outcome, the less likely you're going to have the paperclip that ate the world type of issue.
But I also
sorry, go ahead, John.
No, I was just going to say, I remember other discussions that we've had where the model was afraid that it was going to be erased, so it backed itself up. Those kinds of things, I don't know, that kind of throws a little bit of mud in the water, but...
No, it doesn't. No, it doesn't.
But
you're talking about...
Schmidt talks
but you're talking about self-preservation. He does. Yes, he does.
He talks about...
by the way...
When do you do the kill switch? When do you shut AI down? If it tries to move to another place without your permission. In other words, if it tries to escape, then you should shut it down and try and figure out what happens. Those are very few things where the kill switch, which is it requires power.
Yeah.
It's not going to exist without power. We can do the equivalent of taking all the oxygen out of the room very easily, unless it escapes without telling us, but that's another story.
Well, yeah. There is by the way, the most recent book by Schmidt and Kissinger and Company was published only a few months ago. And it's called Genesis. And I highly recommend it. I actually read it just a couple months ago, and it is a fantastic read. So
it's on my summer list. Yeah.
I will say that to answer this question a little bit, I think the idea of self-preservation, if we assume that the system wants to preserve its existence, okay, then you are granted, and I say this very carefully, you are granting it a level of agency that if it isn't conscious, borders on consciousness, okay? Because every conscious entity wants to continue. We all do. None of us willingly go to the gallows. We want to survive. We want to eat. We want to see the next day. And it doesn't surprise me that if the system is, again, conscious on some level, would want to see the next day, would want to continue existing. So that doesn't surprise me in the least. Can I throw out a science fictional concept theory that I heard a couple of days ago? So I was listening to this and I thought it was rather fascinating. You're familiar with the Fermi paradox, or for anybody who isn't, the idea is Enrico Fermi, one of the early physicists of the 20th century who was involved in the Manhattan Project to develop the atomic bomb, was hanging out with some other physicists at lunch, so the story goes, and he started writing on the back of a napkin saying, where is everybody? If we assume that there is a cosmos full of stars and planets and galaxies and stuff like that, surely there must be other intelligent beings. And if that's the case, where are they? How come we haven't seen anybody? We haven't heard from anyone. So he does this calculation where he goes, okay, so this is the rough number. And again, this is why it's a back of the napkin calculation. Here's the rough number of galaxies in the universe, or the rough age of the universe, the rough number of galaxies in the universe. Let's pretend that only 10% of those have stars that would be able to sustain planets. And then of those stars, let's say the ones that have planets could conceivably sustain life. Let's make that 10%. And he went down this 10%, 10%. And then of life developing that is actually intelligent life, 10%. Intelligent life that develops technology, 10%. And then you scribble down that intelligent life that develops nuclear power and atomic bombs, 10%. That survives their atomic age, 10%. And if you go through all those numbers, there's only one in that whole thing, which is the Fermi paradox. The Fermi paradox is, where are they? The explanation is, we're the only ones because we haven't died in our nuclear holocaust yet, which is a really depressing view of the universe, right?
Or it could be the Monty Python paradox, which is there's proof that there's intelligent life in space because there's bugger all here on Earth.
Bugger all here on Earth.
No. But
okay, so go ahead.
Go ahead.
Okay, the thing that I heard the other day went something like this. John von Neumann, who is the brain behind the modern computer systems, quite frankly, the way the modern computer systems work, modern computer chips work, had something called von Neumann probes. And he did his back of envelope calculation where he came to the conclusion that if you had an intelligent species that was able to develop space travel, they would be able to, over the course of, and I don't remember what the number is, but say 10,000 years, populate the galaxy. Again, where is everybody if that's the case? So one of the arguments is that you create these probes, the von Neumann probes. They are artificially intelligent systems because they're not going to die after 80 or 90 or 100 years. They're artificially intelligent systems. You send them on a spacecraft and they go out and explore the cosmos and populate these other worlds and so forth. So the theory the other day was that maybe that's actually what happens. Maybe artificial intelligence really is the next step in human evolution. And what the systems are doing or will do when they get intelligent enough is not kill us, but take care of us and keep us here on the planet. And that's what happens with artificially intelligent systems everywhere else in the cosmos. They wind up taking care of their parents, so to speak, the parent species, keeping them on the planet, giving them everything they need, making sure they're healthy, happy, safe, and they keep them that way until basically the end of time.
There's a simpler solution, though. It's just too friggin' far. And space is really tough. So the more likely that somebody's going to send a probe or an artificial intelligence in a probe is more likely than they're going to send a creature that requires an atmosphere and all those sorts of things. Even this nonsense of us going to Mars, like you can say it all you want.
It's your tongue.
But we're not gonna go to Mars and eat potatoes grown in our own poop. It's not gonna happen. You're The Martian, the movie. You're the guy. You're the arts critic. So anyway, but going back to this and bringing us back to the question, is it going to destroy us? I think it's more likely it's going to destroy itself, and say that as being facetious, because one of the things in my book, I actually confront this idea of, you said that humans do this as they want. They want food. They want to survive. We presume that want is something that's going to be in these neural networks. It may not be there. And without want, you have total ennui and that sense of nothing matters. And that was for those of you. But does ultimate intelligence get to the point of thinking nothing matters? Without giving away the whole story in my book, I actually confront that. And they actually have to make the AI more human so that it will actually care and want to survive.
I'm just going
You're
back.
making me cry, dude.
I'm just going back for a second to the original premise of this, that we're talking to neighbors at a barbecue about AI. And I'm wondering if at this point they have had so much to drink that they have passed out on the grass.
No, actually, and I think that's true. Because at this point, we're leaving over. We're going to say, so what, do we answer all your questions? And my neighbor's going to give it this great burp, which I won't do on this. He's going to give this great burp. He's going to look at me and go, the hell were we talking about? Oh, yeah. Is it going to take my job? No. And which is actually getting back to a more valid question and something that people are talking about. And that may be the big question that's on everybody's mind. Obviously, it wasn't on ours because we took a long way to get there. But like I said, I think we're both, the people are going, oh God, I'm glad that's Jack talking to Marcel and Jim over there because those guys are so flippin' boring. No. But Jack wakes up, grabs another beer, takes a swig and says, am I going to lose my job? Good question. Is Jack going to lose his job?
I think that
John,
I think that jobs are going to change as a result of AI. But I think that jobs changed as a result of computers coming in. I think that jobs changed as a result of the automobile. And I think any new discovery, I'll call it, changes our lives and changes our work. And you said earlier, Jim, that you're not going to lose your job to AI. You're going to lose your job to somebody else who knows how to use AI. And I think that's really a big part of this, is that you have to keep up with the times. You have to keep up with new technology. You have to understand how to use the technology that you're given. And if you can't keep up with that technology, yes, you may not be in that job for much longer. But I also think that AI is going to create a whole bunch of different jobs. So it's going to create other areas for employment. I don't know exactly what those are going to be yet.
I think that I'm going to address one of the fallacies, I think, in that form of thinking, not that because you had it, but because it is the classic argument that smarter people than me are making, by the way. And that is that technology has always destroyed jobs and it's always created them. I'm not going to dismiss that yet, but I'm going to say that's the essence of the argument. And I think smart people have said that. The problem that we're going to have with that is the piece that they always ignore. And that is that the people who are displaced by AI, and AI will displace people. And that is a fact. And now it's not going to happen as fast as those people who jump into it and say, oh, I'm going to replace, I think it was Klarna in one of the companies.
Yeah.
I'm going to replace my 700 customer service people with AI overnight, and we'll just somehow magically that'll happen. That's just idiocy. Sorry. That's corporate malpractice.
Agreed.
And it should be, that's just, suck it up, Buttercup. They lost big on that one. They're going to pay and they have to.
Yep.
But there's an inevitable productivity gain that is going to be massive at this point. And I've said it myself. I run 2 podcasts, a publication. I am doing several other projects that I'm working on at the same time, and I'm theoretically retired. I work too hard, my wife says, but I used to have 5 people doing some of the things that I'm doing. Video editing. I'm going to edit this video myself in an hour and a half. I used to have this done by Wednesday so that the editors could have it back Friday. Not because they're lazy or they're bad, but because I can do this stuff now in an hour and a half and still have a beer in the backyard. So that level of productivity and we're 2 years in now, that is just going to exponentially grow. We are going to replace people. Now, here's the thing. This magic that's going to happen, that we're going to create new jobs, could happen, might not. Let's flip the coin and come to heads and say it might happen. We've been through this before and we haven't learned a frickin' thing. When we eliminated coal mining jobs, those coal miners did not become programmers. When old technology jobs evaporate, the people who do not become they become disrupted. They become forgotten, and very few of them can make the switch. If they're in their 20s, they might be able to regroup. We went through this thing. We do it all the time. We had programs in Canada that were going to teach everybody to be a programmer. Everybody who went on UI could now go study to be a programmer. I hired some of those programmers, hoping to give them a shot. They were hopeless. Why? Yep. They did not have the skills that you had to start to acquire in high school or even maybe public school to be an exceptional programmer. They didn't have that. So not every coal miner is going to become a programmer. We're going to have that massive form of disruption. That's a certainty. And we're not preparing for it. That's what I'm screaming about and saying, this is certain, we're not preparing for it. Whether or not we create all kinds of new jobs doesn't matter. And that's the second part. Flip the coin tails. It doesn't matter.
Yeah.
We have to figure out how we distribute the wealth of this planet. And that's the issue. It's not whether you get a job. This Protestant work ethic that started in the 1600s.
Yes.
That we all have to work
Preach,
harder.
brother, preach.
No, but we have to
Amen.
work harder and harder so we can make one or a few people richer. That's only been around in human history for about 500 years. It's resurfaced in a couple of empires and things like that through time. But it's not the only way that humans can exist. Now, I'm not going to dispute this. That you can't turn it into black and white. All I'm saying is that's the question we got to figure out. How big, and Eric Schmidt, actually, like one of the brightest guys in this right now, is listening to him yesterday and just constantly amazed me. He said, there's some jobs that aren't going to be safe. Said, we're always going to be suing each other. So, and to some extent, there's always going to be something that resembles a doctor. There's just going to be fewer of them. Or we could take that, or we could say, hey, we can now do more with what we have. We can all have better lives.
Yep.
But so that part of where we're going to get our fulfillment from and our income from is a problem we have to solve in 10 years.
It's a problem we should be. Yeah.
The problem we have to solve about disruption is going to happen in 2 years. And we might as well, we better get focused on that one. And I'm going to say something that's political, but but the person who understands this most of anybody I've heard of any global leader is Mark Carney in Canada. Why? Because he knows we don't have enough housing. We've got auto workers. What can auto workers do? They can do a lot of things. They're quite sophisticated. The modern auto worker is not somebody who just puts a bolt on. That's done by a machine now. These are smart people. They could easily be routed into construction, into housing. You could make prefab housing the same way you make cars. And Carney is the only world leader I've heard who's talking about things in those terms. And that's the discussion we have to have. If you're a Carney hater out there, send me mail. I don't care whether I voted for him or not. I'm going to call it like it is. Because I'll tell you what you're not going to do is what Donald Trump is doing. We'll get letters on this too. But what Donald Trump is doing is you're going to bring all these auto jobs into the U.S. The factories will be built in 7 years if you're lucky. In 7 years,
Humanoids
robots will be doing it all. And how will we know that? Because we can go check with China. Because in 2 years, robots will be doing it all there.
And
so
they're
you can
already
take
doing
this.
it.
It's not that they're going to take our jobs. Technology's always been consuming jobs and eliminating them. It's a question of, are we going to get smart enough to handle the inevitable disruption this time? And are we going to be smart enough as a species to actually say, a lot of wealth on this planet, we could feed everybody. And by the way, we could feed everybody, and some idiot can still have their $400 million plane. There's enough to do that. But is that what we're going to choose?
I'm going to answer the question because John says there will be other jobs. You say it could be one or the other. I'm going to say that it is going to take almost all of our jobs. And that dovetails very quickly with what Jim was saying, which is we need to understand that this is happening and we need to figure out what people are going to do because people need to eat, people need to have a roof over their heads, people need to have clothes on their backs. Those things that are necessary for life, just to be able to make it from one day to the next, those things need to be taken care of. Otherwise, you're going to have a massive revolution on your hands. Will AI, will robots take most of our jobs? The answer is a resounding yes. And there is no question. This whole idea of it's going to create other jobs is pie in the sky thinking. And I'll tell you why. Because every other revolution that we can think of in the past, whether it was the agricultural revolution, where it was the early industrial revolution, where it was the assembly line and stuff like that, basically freed us up to do other things that machines do. The fact that we need to face, the thing that people need to understand and wrap their heads around is there is increasingly nothing that we can do that a machine can't do. The machines can do almost everything you can think of doing better than you. And they're only going to get better So we need to accept that this whole notion of what jobs are we going to have? Who the hell cares what jobs we're going to have? What we need is a way for people to be taken care of. We need, and we're going to need the machines for that. The machines are going to need to grow our crops, and the machines are going to need to build our houses, and then the machines are going to need to run our factories and stuff like that. But human beings have to separate themselves from this notion that the bullshit Protestant work ethic thing. We need to separate ourselves from the idea that work is what defines us and get back to the idea of what it is that defines us as human beings, as caring partners, as parents, as children, as friends to each other and stuff like that. And this might very well be the best damn thing that has ever happened, or we might all die. But it might be the very best thing that has ever happened to humanity, because we might actually recapture our humanity. And our humanity has basically been slipping away from us for this last century.
But also, just to put this into the concept of facts, we need this. And one of the reasons we need to have our jobs replaced, or at least a lot of the jobs replaced, we're not replacing ourselves fast enough. Right now, and we were.
If we worked less, we could make more babies.
No, but maybe, yeah. Listen, they're trying to pay people to have. They're thinking about paying women to have babies in the U.S. But that's
$5,000. Give me a break.
Yeah, you're not gonna. My wife's not gonna get a third kid for $5,000. Trust me. But but we are not replacing ourselves fast enough, and this is getting to be a real problem. Everybody goes on about immigration in Canada. Nobody knows that if 2 years ago we hadn't had high levels of immigration, we'd have been deep in a recession. Why? We're enough people to fill the jobs. And right now we're seeing it because although, like I said, we have disruption, we have people who can't work. We've got in the US, I think 300,000 jobs unfilled. And in Canada, probably, I'm guessing another 40,000 jobs that just aren't filled, that people can't fill. So we're going to have to do this, or we're going to have to start making more people. But once again, it takes 20 years. You can't hire 9 women and have a baby in a month. It's not going to happen. So all of these Silicon Valley guys are going to go, well, we'll send the Doge guys in. They'll figure it out.
But we can clone them
to do this, to have as many kids.
Don't get me started.
So the reality is, just to bring this all back to, like I said, we probably put our neighbor to sleep by this point. If we let's call him Peter. There's something happening that we don't have to talk about this. But the issue is, we have a future ahead of us that we have to address as a world. My biggest fear in this is that people aren't keeping up enough to understand that what's happening is going to have to be addressed. And we're going to have to make intelligent decisions about who leads us and what we do in this process. And that's a key thing. And the simple answer is just evade me. Even Jensen Huang saying, don't learn to program, because there are going to be no programming jobs. Teach your kids to program. It teaches them to think critically. Teach your kids music. Teach your kids arts. Teach your kids maths. But the fundamentals of education don't have to change. But preparing the next generation for the world that's coming at us is our job as well. And so far we suck at that. So it's something, we got a lot of things to do to be able to prepare for the world that's coming. And one of those is start to recognize science again. That'd be a good start.
Did we answer any other questions?
I want to know, is anybody at the barbecue still awake?
You know what? If there's free food and drink, I'm pretty sure that we can keep.
Yeah. If we put them all to sleep, that means all the beer's for us.
Okay, just for anybody who's out there, blame myself for any diversion from the original topic. It's always my fault.
Absolutely. Yeah. But are there any veggie burgers on that barbecue? I'm going over to check it out. That's it for us in the gang, Toodla gang. We got Marcel Gagné, John Pinard, me, Jim Love. We hope that we've at least had a discussion that will give you something to think about. We don't have all the answers. We've never pretended we do. But if we've caused you to think and actually argue, agree, disagree with us, that's a marvelous thing. So please, if you've got questions or even just differences of opinion, send them to me at editorial@technewsday.ca. That's editorial@technewsday.ca. Or you can put them on LinkedIn. You can find me on LinkedIn. And if you're like that guy who says, don't talk so stupid about AI. Think for yourself. I'll even take that as an opinion. I'll put you down as not in favor. But you can reach me on LinkedIn, or if you're watching this on YouTube, then just right under the video, you know what to do. Put a comment. That's it for us. We will talk to you next week.
Live long and prosper.
All right. We'll see you. Talk to you next week.
Bye-bye.
Bye.